The definition of work is a force acting over a distance. So, it's not too surprising that the formula reflects this. Work equals force times the change in the distance. This just means if you have two distances, if you start at 10 feet away and you end up 40 feet away, that was a change of 30 feet. And so make sure if you have two numbers, you subtract them. Whereas if you're just given the total distance that you traveled, you don't need to worry about it. So that's what the little delta, the Greek letter delta means, is change in, which means sometimes you might have to subtract. So work is force times the distance. If you forget, they tell you that W is work, F is force, and D is position, which is how far away you are from something, which is your distance. So work is force times distance. There's the formula. And it turns out that work is in joules, force is in newtons, and distance is in meters. Remember, force newtons are like fig newtons. Force newtons, fig newtons, I don't know, it helps me remember. You might work for gold in joules. Of course, it's not spelled that way, but this is named after Sir James Prescott Joule, and this one's named after Sir Isaac Newton. And that's why capital J and capital N for the letters of their last names. So to have work, you must have a force, and it must move over a distance, meaning that there must be motion. And finally, the force and the motion have to be in the same direction. For example, if this girl pulls her suitcase along the floor, her force is to the right, the direction of motion is to the right, and all of her force is used to do work. However, if she pulls the suitcase at an angle, the sideways force does work because it's used to make the suitcase move sideways. But the upward force exerts a force but does not do any work because the suitcase does not move upwards. Isn't that weird? And then if she lifts the suitcase and carries it, her force is in an upward direction and the motion is sideways. So now she's actually not doing any work at all on the suitcase. That just blows my mind. So let's look at some more examples to make sure we're on the right track. For example, if I hold an object up over my head, am I doing work? Well, let's think about the definition. Am I exerting a force? Yes, if I wasn't exerting a force, these paper towels would fall. But is there motion? Am I moving it over a distance? No, it's staying still. Therefore, I am exerting a force on the paper towels, but I am not doing any work on the paper towels because they aren't moving. What if I lift these paper towels up over my head? Now am I doing work? Well, let's think about it. First of all, I am exerting a force in the upward direction, and there is motion, and the force and the motion are both in the upward direction. So yes, I am doing work on the paper towels until, of course, they come to a stop. What if I push a desk or a chair? Am I doing work? Well, I exerted a force, and it moved, and the force and the motion were in the same direction. So yes, I was doing work. What if I pulled the chair instead? Well, that's okay. There was a force, there was motion, and they were in the same direction. Therefore, I did work. How about if I push on this wall? Am I doing work? Well, did it move? No. So I'm not doing work. Yes, I'm exerting a force. Yes, I'm going to get tired. But believe it or not, I'm not doing any work because there isn't any motion. So you have to be really careful with the definition of some of these physics terms because you have to follow that definition to get the question right. Now here's the weird one. What if I carry this paper towel across the room? Well, am I exerting a force? Yes. Is there motion? Yes. But is it in the same direction? My force is upward. My motion is sideways. Since those two actions are at right angles to each other, I am not doing work on these paper towels. Isn't that weird? What if I roll a ball across the floor? Am I doing work on the ball? Well, as long as my hand is in contact with it, yes, because I'm exerting a force, and the force and the motion are in the same direction. But what about when I let go of it? Can I exert force on the ball once my hand is no longer touching it? No, I'm not Hermione Granger. I can't make that ball move. Therefore, since I am not exerting a force, I am not doing work on the ball once it leaves my hand. Let's do an example problem. How much work does a 25 Newton force do to lift a potted plant from the floor to a shelf 1.5 meters high? First of all, let's go through and pull out all of the information given in this problem. How much work is done? So work is what we are looking for. How much work does a 25 Newton force do? Oh, 25 newtons is a force. And we lift the potted plant from the floor to a shelf 1.5 meters high. 1.5 meters is the distance. So now we must find a formula with work, force, and distance. Of course, that is work equals force times distance. Now we need to put our formula into a triangle. Since force and distance are being multiplied, side by side multiply. So force and distance go side by side in the triangle. Work goes in the empty blank, which happens to be at the top. Now let's solve our problem. We are looking for work, so cover up work, and we'll want to do force times distance. So 25 newtons times 1.5 meters will give you 37.5. Now, what unit do we use for work? Oh, you work for gold and jewels, so work is in joules. Next, let's talk about power. Power is the rate at which work is done. It's how fast you do the work. So for example, if I'm driving a little Nissan Sentra with 4 cylinders up a mountain versus my husband's driving a big Ford F-150 truck up the mountain, who can get up the mountain faster? Definitely my husband, because his truck has much more power than my car. And that means he can do the work of using a force to pull up the mountain. He can do that work much faster than I can. So to do work faster, you need more power. The formula for power is work divided by change in time. You can just ignore the change in and put in the time. But just realize that if they tell you you start at 5 minutes and end at 20 minutes, oh, that's a difference of 15, and so the change in time was 15 minutes. In other words, you might have to subtract, or they might just hand you the time. So be careful, this P is not momentum. This P is. This P is power. Power is work divided by the change in time. You can just ignore the change in and use work divided by time. When you fill in this formula into the triangle, it's a little bit different than last time. Power is work divided by time. Work and time are being divided, not multiplied. Therefore, work has to go on top and time has to go on bottom. If you put time on the right instead of the left, it's totally fine and you'll still get the right answer. Power goes in the leftover blank, which happens to be on the bottom. Now, your family is moving into a new apartment. While lifting a box 1.5 meters straight up to put it on a truck, okay, meters, that's distance. Wait, this formula doesn't have distance. We'll figure that out in a minute. You exert an upward force of 200 newtons. Okay, so that's the force for 1.8 seconds. That's the time. How much power, we're looking for power, is required to do this? Oh boy, we're looking for power. So we have to do work divided by time. Well, we have the time, but we're missing work. That's okay, just use that other formula. Work equals force times distance. Now when we had division, the W went on top, the T went on bottom. When we have multiplication, F and D go on the bottom. and W goes in the leftover blank. It happens to put W at the top, but that won't necessarily happen every time. So always remember, are you dividing or are you multiplying? Put division on the top and bottom, put multiplication side by side, multiply. So first we have to find the work by doing force times distance. The force was 200 times the distance was 1.5. Do your math, and you'll get 300 joules of work. Now we can do power, cover up power, and work divided by time will give you power. So there's your work, divided by time of 1.8 seconds. And finally, our answer is 167. Now, we just found the power. Power is in watts. W-A-T-T-S. You can abbreviate that with just a capital W. This next problem is very similar to the first one. Go ahead and try that one now.